so section 2.2 is going to be all about solving linear equations and eventually getting to applications at the end of it. Alright, so understanding and solving equations and applications, and specifically we're going to be looking at the linear case. We will expand the linear case later on, but right now we're focusing on the linear types. Alright, so learn about linear equation, recognize linear equations and their solutions. We're going to solve them symbolically, which basically just means algebraically, but that is the term the book uses, so make sure you understand what that means using symbols. So that's algebraically. Graphically, and then numerically, and graphically kind of go hand in hand. Alright, and we'll get there, and we'll kind of do that on the calculator. We're going to solve application problems. We're going to look at percentages, because again, it's always important to understand. A lot of applications give you percentages, so you should understand what a percentage is, how it relates to the decimal and the fraction. Solve for variables. Sometimes we have to solve an equation for a variable. And then we're going to look at different types of applications. Now, there's lots of different types, but I'm going to hit the 4 sort of big ones, and the 4 kind of harder ones typically for students. An equation is a statement where we place two mathematical expressions equal to each other. So again, in order to be an equation, there has to be an equal to something. Right? If there's no equal sign, then it's just an expression and not an equation. Right? So again, it has to have some expression equal to another expression. And so some examples here: x plus 15 equals 9x minus 1. Z plus 5 equals 0, right? There's an equal there. 1 plus 3 equals 4, right? That's an equation. And so on, and the other examples there are a little more complex, but they're all equations, right? Equations are just when I have algebraic expressions set equal to each other, right? So they involve an equal sign. If they don't have an equal sign, they're not an equation. They're just an expression. All right, we're going to get into solving equations. Solving equations means to find, and that's a big concept in mathematics, especially at college algebra. All right, solving equations means we want to find all of the values, all of the numbers, the numerical values, the answers, of the variable parts that make an expression true, to make one of those statements true. I want to find all of the numbers I can put into my equation to make the equation true. All of the solutions are called the solution set. Solutions should always satisfy the equations. And we call two equations equivalent if they have the same solution set. Right? So if they have the exact same solutions, they're equivalent expressions, even if they're written differently. Kind of like, actually, the easiest example is looking at the one above, where it's 1 plus 3 and 4. Right? 1 plus 3 is an algebraic expression. 4 is an algebraic expression. They're different expressions, but they're equal, right? They're the same. Right, there are 3 types of solutions that you can get when you're solving equations. All right, so 3 types of solutions. The first solution is the identity solution, and this basically happens when you've got 2 expressions that are equivalent set equal to each other. All right, so it has meaning. It actually gives us an example of when we get that special case, a special case. So a simple example is when I have 2x plus 3 equals 3 plus 4x minus 2. Right? So 2x plus 3 is a different expression than 3 plus 4x minus 2. It's an equation because I've set them equal to each other. And then we solve. So we simplify. The first thing that you'll do is you combine your like terms. You take your 4x minus your 2x, so you get 2. And so now here you'll look. Once I do that, it's easy to see that they're equivalent expressions. And then what happens here, we get the 2x plus 3 equals the 2x plus 3. If you move one of the 2x's to the other side, right, I subtract it from each side. And then what happens is you're left with just 3. All right, 3 equals 3, which is always true. And so whenever you get a statement like that, where you have 2 sides of the equation that are exactly the same, right, it ends up with the same number, that statement's true no matter what x value I plug in, right? If I go to the original expression, I plug in any x value, I'm always going to get 3 on both sides. And so what the answer is there is I've got 2 equivalent expressions. So both of those equations have the same solution set. And so the same solution set means the solution to this equation is all real numbers. Anything works. I can plug anything I want from negative infinity to positive infinity, and the equation will be true. All right, so all real solutions, my solution set would be going anywhere. I could pick anything from negative infinity to infinity. Alright, so that's a special case. Right, the second one is also a special case, which is still a perfectly fine answer in mathematics. It's perfectly fine to say there's no solution. Right, that's the second special case. It's called a contradiction equation. It's whenever you get an equation where you get a false statement out. Alright, so an example here, I have 2x plus 3 equals 5 plus 4x minus 2. So it's very similar, I just changed the constants. So again, this side simplifies to 4x minus 2. That 2x will cancel with that 2x when I move it to the other side. But then I'm left with a 3 on one side and a 5 on the other. Alright, and so the last statement is saying 3 equals 5. Well, 3 does not equal 5. Right, if I've got 3 apples and 5 apples, that's different, right? They're not the same. Somebody's got more apples than somebody else. And so that's a false statement. Whenever we get a false statement out, something that's untrue, well, the answer is no solution. And that's a perfectly fine answer, right? We will get that in mathematics. And sometimes we need that. We need to know that this isn't possible, right? If you're working on some engineering project and you need to know, well, can I do this? And they solve it and they crunch the numbers, they go, nope, you can't. It's impossible. You have to, come up with a different design because you can't do this. There's no solution to it. Which, again, like I said, is a perfectly good answer. And the first two examples are sort of special cases. The identity and the contradiction are special cases. The one that occurs the most often is the conditional equation. This is the one where we'll get a solution or more. We're going to have more than one solution. But this is when an equation satisfies, when will have some answers. We'll have infinitely many like the first outcome. But there'll be specific, exact numerical answers that solve my equation. Alright, so again, some of the real numbers solve it, not all of them, so it's not the first case. And for a lot of our examples, there'll be 1, 2, or 3. There'll be one answer to the solution, 2 answers, 3 answers. And so that's what the outcome is. And I gave you 2 examples here where we get 1 outcome and then 2 outcomes. So the first example, we get 1 solution. So again, start off with a similar type equation that I had earlier. I just dropped the negative 2x. If you'll see, this is just a 4x over here. And so when we solve this, so what we did, and again, there's kind of a step skipped here, and I'll get to solving because we haven't really talked about the identities yet. But what I've done here, is just so you can see the example here, is we move the 4x over and the 3 back, so we have to subtract 4x to move over the 2x. Alright, we got 2x plus 3 equals 5 plus 4x. And what they did is we moved the 4x over and then the negative 3 over. So that 4x cancels out there, that 3 cancels out there, so I'm left with the 2x minus 4x on that side, 5 minus 3 on that side, and then we combine like terms. We get the 2x minus 4, which gives me a negative 2x, 5 minus 3, which is 2, and then the last step, I'll put 3 instead of 2. We divide out the 2, and so negative 2, and so we get x equals negative 1. And so there's a 1. And we'll talk about that more. Actually, we'll go over identities, but that's what's going on in case you want to know what's going on. But whenever we get an equation where there's exact numerical answers, and that it's not infinite, there's just a one or a few answers to an equation, that's the conditional event, meaning only these x values work. Not all x values work, but these x values, these numbers work. So the first example, I get 1 solution. The second example, I get 2 solutions. And since we haven't talked about quadratic equations, I'm not going to talk about how that one's solved. But if you know how to solve it, that's fine. We'll get there when we get to quadratics. Right, but that one would be an example of 2 solutions. Right, if I plug 1 in to x squared, I get 1 out. If I plug negative 1 into x squared, I get 1 out. So there's 2 solutions to that equation. And there are equations with 3 solutions, 4 solutions, all right, and many solutions out there. We're going to focus in this chapter on the linear case, where we get one variable linear cases. Alright, so one variable linear equation can be written in the form of some x term, some ax plus some constant equals a 0 if I wanted to, where a and b are just real number values, or constants, and they're not 0, right? A can't be 0. I have to have a number in front of it. So I gave you some examples here of one variable linear solutions. Alright, so one variable linear cases. And then we're going to get into how to solve these one variable cases. Alright, so that's where we're going to pick up the next video.